All right. Fundamental theorem of algebra. Given 1, 0, find all the zeros of the polynomial. All right, so this is telling me that x is equal to -2. That this function, polynomial, that it for sure crosses the x-axis at -2. So it's definitely a 0. So this is what we're going to use for our synthetic division process. Okay. The variables in the polynomial, we're missing an x cubed. They are in descending order. So grabbing the coefficients, we have 1, 0, right, because x cubed is missing. -9, -4, 12. Okay. Starting the synthetic division process, we bring down first coefficient. We multiply times -2. So -2. And then we add. So 0 plus -2 is -2. And you start the process all over again. -2 times -2 is +4, plus -9, -5, times -2, 10, plus -4, 6, times -2, -12. And we get 0. Okay, and that was expected because they told us that it was a 0. All right, well, because this is a 4th degree, we know it's going to have 4 zeros. So we need to find 3 more. All right, this is going to take some trial and error, but from the rational zeros theorem, we know that if we take the factors of 12 divided by the factors of the leading coefficient, which in this case is 1, we can get a list of numbers, right? So we can call this plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. All right, so one of these numbers, technically -2, that was on the list, so it'll work. We could try 1, -1, maybe +2. -2 might work again. I mean, really, it doesn't matter where we start. The fact is that we start. So I'm just going to start with 1. Okay. Bring down the 1. 1 times 1 is 1, plus 0, times 1, plus -9, times 1. It's going to be -8. When we add -12 times 1, okay. So that means x equals 1. So x equals -2, x equals 1. What's cool, I guess, in a sense, is that because this was a 4th degree, when we decrease it by 1, and now we're going to decrease it again, we're going to get x squared Oh, okay. So I made a mistake. But it's all good. It can, well, we found out that 1 is definitely a 0. However, it's best if we use synthetic division here. Not on the original. So it should work out, right? If it's a 0, it doesn't matter where it works out. It's going to work out regardless. So 1 times 1 is 1. negative 1 times 1, negative 6, 6, negative, and 0. Again, that was expected. So again, x squared and x. So we can factor, well, maybe, x squared minus x minus 6. So two numbers that multiply to make 6 that add up to 1. So 1 and 6, 2 and 3. I think it's going to be 2 and 3. And this is going to be, so it's negative 6. So one of them has to be negative. And it's going to be the bigger one because this is the sign right here. All right. So our four roots are going to be so it's a set, right? Like these four numbers create a set. So negative 2, 1, and 3. It's probably how you'll typically see it. But right, take note, because it was a fourth degree, there are 4 zeros. That's what the fundamental theorem of algebra says, that it will have 4 zeros, right? Whatever that degree is. In this case, they were real, so it may not always be that way. Okay, number 2. Okay, the root that they give us, the complex number, 3 plus 2i. Immediately, we know the second root, or we know a second root, right? 3 minus 2i. Complex numbers, i's always come in pairs. So I'm going to use synthetic division. So 3 minus 2i goes in the box. So we got in descending order, 4, 3, 2, 1. Okay, so all the degrees are there. So 1, negative 6, 12, 6, negative 13. Bring down the 1. 1 times that is going to be 3 minus 2i. Adding just the real part, or combining the real parts, negative 6 plus 3, negative 3 minus 2i. We're going to need some side work. We have 3 minus 2i, negative 3 minus 2i. All right, using FOIL, get negative 9, negative 6i, positive 6i, positive 4i squared. Combining like terms, we get negative 9. Those cancel. And this would be minus 4, right? Because I squared is really negative 1. So it just flips the sign. So we're going to get negative 13. Okay, when we add, this is going to be negative 1. It's kind of nice. All right, times 3 minus 2i, negative 3 plus 2i. When we add, we're going to get positive 3 plus 2i. Okay, when we multiply, we're going to get 3 minus 2i. Okay, conjugate pair, that's actually kind of nice. When you have a conjugate pair, right, they're identical except for the symbol. First times first, last times last. This is going to be negative 4i squared. I squared is negative 1. So this is going to make this 9 plus 4, which is 13. When you add, we get 0. Okay. One more time. We're going to use, so we used this one. Now we're going to use the given one. Doesn't matter which one we use first. It doesn't matter. But we're expecting a 0 to happen, right? Because it is a 0. So bring down the 1, we multiply 3 plus 2i. When we add, we're going to get 0, 0 times add times, we're going to get -3, -2i. When we add, we're going to get 0. So we started off with x to the 4th, x cubed, x squared. So this is x squared minus 1. And this is a difference of squares, right? Perhaps you don't see it, but a squared minus b squared is equal to a minus b, a plus b. In this case, x is a, b is 1. So we got x minus 1, x plus 1. So our 4 roots, right, because this was a 4th degree. Right, that means 4 roots. They are x is equal to 3 minus 2i. X is equal to 3 plus 2i. X is equal to 1. X is equal to -1. We could have wrote it in set notation if we wanted. This is fine. Okay, x cubed, x squared, minus 4x, minus 20. So they're all there. They're all in descending order. X is equal to -5. So that's the number that's going in the synthetic division box. And then we grab the coefficients. Start the process. Bring down the 1. We multiply. -5. We add. That's nice. When we multiply, we add -4. When we multiply times -5 is +20. When we add, we get 0. Okay. So again, 3rd degree, 3 roots. So if it was x cubed, now it's x squared, right? Because we decrease it by 1. So we're going to get x squared minus 4, right? Because this is just x. Okay, so we can factor this. This is definitely a difference of squares, right? Because we could rewrite this x squared minus 2 squared. And now x is a, 2 is b. So it's going to be x plus 2, x minus 2. All right, so our 3 roots are x is equal to -5, right? That was given. Then x is equal to -2, and x is equal to +2. 3 roots. All right, this one's going to be fun, I can already tell you. So the second root immediately, right? Because we know a complex number and i's come in pairs. So this is going to be 4i. Doesn't matter which one we use first. Let's use the negative one just to get it out the way. So -4i is what's going to go in the synthetic division box. Notice, first thing I check for is it in descending order. We're missing an x cubed and we're missing an x. So the coefficients are going to go 1, 0, 15, 1, -16. Bring down the 1. When we multiply, we're going to get negative 4i. When we add, we get negative 4i. When we multiply, positive times a positive is positive. No, a negative times a negative is a positive. So positive 16, I squared. But I squared, right? Look, if you can't visualize it, that's fine. So it's going to be positive 16 I squared, which is basically negative 16, right? Because this is really negative 1. So negative 16. Plus 15 is negative 1. That's nice. Multiply by negative 4i, we get positive 4i. When we add, we can't combine, right, complex part and or imaginary part and a real part. So we're going to get 1 plus 4i. Okay. When we multiply, it's basically going to distribute. And we're going to get, I already don't like this because it's a root. This should equal 0. I have a feeling it's not, because look what's about to happen. Let's see. This is going to be negative 4i times 1 plus 4i. So negative 4i, negative 16i squared, which is basically negative 4i plus 16. That's a complex number, though. It's supposed to be 0. It's supposed to be 0. What's happening here? Okay, so 4th degree. So x to the 4th. X cubed is missing, so we got 0. Oh, I see why. You probably saw it already. This should be 0, right? This should be a 0. All right, so when we multiply negative 1 times negative 4i, we get positive 4i. So when you add, we get 4i. So when we multiply positive 4i times negative 4i, we're going to get negative 16i squared. So we lose I squared, flip the sign, we get 16, and we get 0. So that was as expected. All right, because this was x to the 4th, this is going to be x cubed. And we're going to do synthetic division, but with positive 4i, right? Because that's the other root. So bring down the 1, and this one should be nice. Right, it's always nice the second time through. Right, the second iteration. When you do a complex number, that first time it's always complicated. The second time it's always easy. When you multiply, this is going to be positive 4i. When you add, you get 0. See what I'm saying? So when we multiply, we get 0. We add negative 1. We multiply, we get negative 4i. Then we get 0. Okay. This is a x squared, that's quadratic. So x squared minus 1. This is a difference of squares. X minus 1, x plus 1. So our 4 roots are x equals positive 1, x equals negative 1, x equals negative 4i, x equals positive 4i. That one was fun. Okay, 2 more synthetic divisions. These do get progressively harder. Okay, so it's a 4th degree, so we know we need 4 zeros for sure. They gave us 1, 2i. i's what? Come in pairs. So negative 2i. So let's do 2i in the box. Is it in descending order? 4, 3, 2, 1. Yep. So 1, 4, 7, 16, 12. Bring down the 1. We multiply 2i. We add 4 plus 2i. That's fun. All right, when we multiply, the 2i is going to distribute. All right, so again, this first iteration with the complex number sucks. But, we're not scared. So this is going to be 8i plus 4i squared. So I squared is really going to change the sign. So it's going to be, 8i minus 4. 8i minus 4. Doesn't matter where you put typically the imaginary part's in back, but 1 plus 2 is the same as 2 plus 1. It truly doesn't matter where. When we add, again, just combining the real parts, we're going to get 8i plus 3, right? Because 7 minus 4. When we multiply, 2i times 8i plus 3. This is going to be 16i squared plus 6i. I squared is going to change it to negative, so 6i minus 16. 6i minus 16. When we add, we get 6i. We multiply, there's going to be 12i squared, so negative 12. Right, I squared is negative 1. When we add, we get 0. Okay, that was using positive 2i. Now let's use negative 2i. Negative 2i. Bring down the 1 times negative 2i. When we combine, add going down, we're going to get 4. Times negative 2i is going to be negative 8i. When we add, we get 3. Multiply times negative 2i, we get negative 6i. When we add, we get 0. Okay. So now we're at, x4, x3, x squared plus 4x plus 3. Does this factor? Numbers that multiply to make 3 that add up to 4. 3 and 1. Right? 3 times 1 is 3. 3 plus 1 is 4. Everything's positive, so they're all positive. And now our roots are going to be x equals negative 3, x equals negative 1, x equals 2i, x equals negative 2i. There are 4 roots. Okay, number 6. I have a feeling this is going to be a doozy. Okay, they gave us negative 2i. So immediately, positive 2i, right? I's come in pairs. If you had just one i, it'd be silly. So in descending order, 4, 3, 2, 1, it's all there. So let's use negative 2i since that's what they gave us first. So 1, 1, 2, 4, negative 8. Bring down the 1 times negative 2i. We add 1 minus 2i. Okay. When we multiply, negative 2i times 1 minus 2i. We distribute negative 2i, positive 4i squared. I squared is negative 1. It's going to change the sign. So we say negative 4, negative 2i. So negative 4 minus 2i. When we add, we're going to get negative 2 minus 2i. So we multiply again, it's going to distribute. Negative 2 minus 2i. This is going to be positive 4i. Positive 4i squared. That means it's going to change the sign. So 4i minus 4. 4i minus 4. When we add, combine the real parts, we just get 4i. All right, last step. Negative 8i squared. So it's going to lose I squared and change the sign. So positive 8. When we add, we get 0. Okay. Using the other root 2i, putting that in the box. Bring down 1. We get, what do we get? We get 2i. So when we add, we get 1. When you multiply, we get 2i. When we add, we get negative 2. Right, because we're just combining the imaginary parts. We multiply, we're going to get negative 4i. When we add, we get 0. Okay, this is a quadratic, right, because this was x cubed, and this was x to the 4th. So, x squared plus x minus 2. So numbers that multiply to make 2, negative 2, that add up to 1. Positive 1. So it's going to be the first one. All right, so this is x minus 1, x plus 2. So the roots are going to be the opposite of these factors. X equals positive 1, x equals negative 2, x equals negative 2i, x equals 2i. That wasn't that bad. That wasn't that bad. Okay. Oh, even easier. So I want to write a polynomial function of least degree using the given zeros. So all I'm going to use are what they give us, unless there's a complex number, and then we know that i's come in pairs. Okay, so this means x equals negative 5, right, because that's a root. X equals negative 1. X equals 2. All right, we're going to turn these roots into factors. All right, we flip the sign. So x plus 5, x plus 1, x minus 2. Okay, now we just FOIL everything out. I'm going to do 2 at a time. So x squared plus x plus 5x plus 5. Combine like terms. Then we're going to distribute to x minus 2. All right, we're going to get x cubed The idea is that everything in one gets multiplied to everything in the other. So this is plus 6x squared plus 5x. Okay, this is going to be negative 2x squared, negative 12x minus 10. Combining like terms, we're going to get x cubed plus 4x squared minus 7x minus 10. So there is a function polynomial of least degree that has these given zeros. Okay. Okay. -1, 2, -3i. So immediately, i's come in pairs, so 3i is for sure. So this is going to be, so again, my technique, the way I do it, I write them down as roots. X equals -1, x equals 2, x equals -3i, x is equal to +3i. And then I turn them into roots or factors because they are roots, right? This is like roots and then factors. So x plus 1, you flip the sign, x minus 2, x plus 3i, x minus 3i. Okay, we can start wherever. I like to start with the complex numbers because they're conjugate pairs, right? They're identical, except for the sign are different. So first times first, last times last is all you need. So this is going to be x squared minus 9, right? Because 3 times 3. And I squared is -1, so it's going to change the sign. So x squared plus 9. That's a factor. Okay, I can do x times x, x squared, 2x plus x minus 2. So this is going to be, when we combine like terms, x squared plus 3x minus 2. Okay. Last step. This is going to be x to the 4th, right? Because when you multiply common bases, you add the exponents. This is plus 3x cubed minus 2x squared plus 9x squared plus 27x minus 18. Okay. Combine like terms. We have a square. That's really it. So x to the 4th plus 3x cubed plus 7x squared plus 27x minus 18. Oh, this one's good. -I, let's go. Okay. Again, write them down as roots. -I. Then we turn them into factors. X minus 2, x minus I, x plus I. This is going to be x times x, x squared. I times -I is -I squared. So I squared is -1. So it's going to change this to positive. Times x minus 2. So this is going to be x cubed plus x minus 2x squared minus 2. So writing it in descending order, our final answer, x cubed minus 2x squared plus x minus 2. Okay, last one. This is 4 minus I. That's the one that we're missing. The root. So we have x equals 5, x equals -5, x equals 4 plus I, x equals 4 minus I. Okay, turn them into factors. X minus 5, x plus 5. This is going to be x minus 4 minus I. This is going to be x plus x minus 4 plus I. Okay, let's start with the first two. They seem to be the easier ones. So this is a difference of squares, right? It's a difference of squares in reverse, right? This is your, think of this as like your A. This is your B. This is your A. This is your B, right? A minus B, A plus B. We can write that as A squared minus B squared, which is just 25 basically. So x squared minus 25. Okay. Let's get this next one. So this is going to be I feel like we could do a difference of squares here. Right? Because technically they're conjugate pairs, right? So I mean, there's nothing wrong with distributing all this out. But if you could notice, right here, let me put some parentheses here. Maybe you could see it. So this is like my A. And the I is the B. So I have A minus B, A plus B. So this is a difference of squares. So this is going to be x minus 4 squared minus I squared. And that's nice because I squared is just -1, and it's going to flip the sign. So x minus 4 squared plus 1. And we square a binomial. If you followed my channel long enough, you know when you're squaring a binomial, x times x, -4 times -4 is positive 16. And then 2 times x times -4. So negative 8x. Now we have to multiply this by x squared minus 25. Right, because we're still trying to figure out this polynomial. Okay, so now there's no trick here. You definitely got to just work this one out. So this is going to be x to the 4th. (16) x squared negative 8x cubed minus 5x squared. 16 times 5. 30. Carry the 3. 80. Negative 80. Positive 40x. Okay. Combining like terms, we got final answer. X to the 4th negative or minus 8x cubed. Combining the squares, we have positive 11x squared plus 40x minus 80. Hopefully you got the same thing. All right, good luck.